Hello guys, it's me Sujit, and in today's video we are going to study about the theory of relativity. So basically I would like to introduce myself. I'm Sujit and I would be posting many videos based on theories, formulas, equations about physics, and you will get to see it on my YouTube channel. So let's begin today's session. What is its equation? The equation E is equal to mc squared means energy equals to mass times the speed of light squared. It shows that energy E and mass m are interchangeable. They are different forms of the same thing. Essentially, it's a theory of gravity. The basic idea is that instead of being an invisible force that attracts objects to one another, gravity is a curving or wrapping of space. The more massive an object, the more it wraps and or the space around it. It just describes objects that have mass and that aren't moving. Introduction to relativity. Relativity is a theorem formulated by Albert Einstein which states that space and time are relative and all the motion must be relative to frame reference. It is a notion that states laws of physics are the same everywhere. This theory is simple but hard to understand. It states there's no absolute reference frame. One can measure velocity if the object or momentum is only in relation to other objects. The speed of light is constant irrespective of who measures it or how fast the person measuring it is moving. Special theory of relativity. This theory is based on two postulates. The law and physics are the same for all irrespective of velocity of the observer. Second thing is the speed of light is always constant regardless of the motion of the light source or the motion of the observer. This is a theory which laid the foundation of time travel. According to Einstein, the rate at which time ticks decreases with the increase of the velocity of the person. But this is hard to notice that as the decrease in the time is relatively very low when compared to the increase in time, so it can be assumed that if you can equal the velocity of the light, you will be in a situation where time is still. This phenomenon is called as time dilation. So in space, as time dilation is also called, like in space, the faster you go, the time like remains almost same. So this states that this is called time dilation. So general theory of relativity. It states that being at rest in the gravitational field and accelerating are identical physically. For example, an observer can see the ball fall the same way on the rocket and on Earth. This is due to the acceleration of the rocket, which is equal to 9.8 meter per second square. This theory relates to Newton's gravitational theory and special relativity. So in this picture you can see two persons standing and throwing the ball, but then when the person on Earth in the second picture, he's on rest, and though he's throwing the ball, it seems to remain the same as the person is throwing on the rocket, which is of the speed which is 9.8 meter per second square. These both are same, and this is called as general theory of relativity. Consequences of general relativity. Gravitational time dilation. Gravity influences the passage of time. Clocks in the deeper gravitational wells run slower than in general gravitational level. Light rays will bend in the gravitational field. The universe is expanding and parts of it are moving away from Earth faster than the speed of light. So now it's question time, and I would be giving three questions. So the first question is: theory of relativity encompasses two theories, namely special relative theory and what? I'll be giving you 10 seconds for this and one more question. Yeah, so the next question is which law or the state or states that speed of the light is always constant regardless of the motion of the light source or the motion of the observer. Yeah, so the answers are here. First question's answer is general relative theory. The second question answer is special relative theory. So our next question is, objects are measured and appear to be shorter in the direction that they are moving with respect to the observer. This is typically a bit hard question, which I didn't have taught you. And the answer is here. Length shrinking. So thank you guys for watching this video. If you like my video, please hit the like button below. Please also subscribe my channel and also comment if you have any doubts or like any suggestion for my next video which I should be uploading. And even I'll also be uploading more videos about theory of relativity, not just this one. So please hit the subscribe button and also press the bell icon as whenever I upload a new video you can get the information suddenly. Thank you and have a great day, and we'll meet in the next video.